Hello everyone, my name is Namlin Ejin Madrin and I'm presenting on behalf of Group O. My group mates are Waswajo, Tugume Jonathan, Ocheno Fidel and Atugunza Mathias. We are here two computer science students and we are presenting a safeguarding companion, which is a RAG-based chatbot for safeguarding policies here at Makerere University. So here's the problem. You realize that Makerere University has very strong policies safeguarding students' rights, such as the safeguarding policy on students with disabilities, the sexual harassment policy, and many others. However, much as these policies exist, there is a very big gap between having these policies and actually using them effectively. Many students don't know about these policies, and those who know about them don't know where to find them. Also, the language used in these policies is too complex, plus the documents themselves are text heavy, over 40 pages. So this becomes even more worse to persons with disabilities because these policies are not accessible at all to them. To address this problem, we developed a RAG-based chatbot that retrieves answers directly from these policies. Instead of generating their own answers and hallucinating, it gets answers from these verified policies, breaks them down, and return a more simplified answer such that even when someone has an emergency, he or she can quickly get a solution by interacting with this chatbot. We also added some accessible features for persons with disabilities, such as the adjustable font size, high contrast mode, plus the voice interaction, in order to ensure that all students have equal access to this safeguarding information and equal understanding of their rights. Thank you so much. I invite my colleague to take you through how we process the documents.
Well, greetings everyone. My name is Joshua Job, and my presentation is about how we prepared our data, that is through PDF processing, chunking, and embeddings. We downloaded 6 PDF documents, whereby 2 of them were scanned images. Therefore, we had to extract text from them using PyTorch. And then for the other 4, we read them directly using PyPDF2. So once we had the raw text, we split it into 315 chunks of 250 words each. Then we used a 2-sentence overlap between the chunks such that information at the boundary of the 2 chunks is not lost. Then we tested on chunk size 100, 150, and 250 words. Then finally we chose 250 because it gave us the most complete answers. From there, we converted each chunk into a 384 number dimensional vector using a model called All-Mini LM L6V2. This is what allows our system to understand the meaning, not just capturing keywords. Thank you very much.
My name is Jonathan. I'll be presenting the retrieval system and baseline comparison. How retrieval was implemented. When a student sends a question, the question is checked for a trigger word, which could be HIV, disability, or harassment. Based on the trigger word, related policy vocabulary is added to the question, making it more bulky, hence it's more relatable to the chunks to return viable chunks to the question. The question plus the vocabulary are converted to a 384 dim vector using the same sentence transformer used for the chunks, which then after is used in the semantic search with constant similarity and compared with all the 315 vector chunks, and the top 7 chunks are returned having used the word booster favoring action word, since normally students are looking for solutions. And some of the key parameters that we used, we retrieved 7 chunks, wanting to retrieve the best relevant chunks to the question, and used a threshold similarity of 0.2, given students normally use informal grammar while to communicating to the systems. Yes, yet policy documents have formal language, and a chunk size of 250, believing it's enough for a policy to have its definition, conditions, and who to report to, and a sentence overlap of 2, not wanting to split two connected sentences into different chunks. And then for the comparison, we use semantic search in our project, but we compared it with the TF-IDF search method to see which one works better and to prove our point of using semantic search. Using 5 questions for a test, each having its keywords expected for its answer, it proved out that semantic search performed better, hence making it more viable. And I'll be passing on to my colleague to continue with the answer generation.
My name is Otieno Fidel John, and I'm going to be taking you through how we measured the performance of our model when it was generating answers. Was it correct or not? We used keyword hit rates, and then we also measured the source retrieval accuracy, and then we saw which questions passed, and then we said we wanted to see if we had complete failures. Once the retrieval system finds the most relevant chunks, the top 5 out of those chunks are passed through the large language model called the Llama 3.18b, which is running on Grok. Grok uses specialized hardware called the LPU to generate answers under 1 second, even though it generates plain English mostly. So we put a set of instructions such that the model would bring in only relevant answers based on the content we fed it. It should not bring outside the knowledge base scope, and it should not guess. And when we tested it on 15 questions, and this is the performance we got. We got 100% source accuracy, meaning that the system was only looking at the policy documents when responding to answers. Then for the keyword hit rate, we've put 5 questions such that 5 keyword, not questions, 5 keywords such that each time a question was asked, there was those 5 keywords are expected in the answer to see how accurate the answer was. And when you based on all the 15, the average was 83, not 85. Then for the analysis, question 11 and question 15 was out of the scope. That's why it has a very low keyword hit rate. And then question 11 was too broad, meaning it couldn't find a single chunk to handle the response. Thank you so much. I remain Otieno Fidel Jones, and that was my part.
Greetings to everyone. I'm called Gonzanathias, and I will present 3 things: live demo, limitations, and future work. On our live demo, these are some of the questions the student can ask. Without wasting time, let me directly go to the live demo. Student looks in and asks some of the questions. For example, how do I report harassment? So you get 2 things. One, the possible guidelines, these are the guidelines, and the source of that information where it was obtained. So this is the policy where we get that information. Also, student can ask another question like, what is the university tuition fee for 2025? So we don't have any information about tuition fee. The system will inform the student about that. Like, I'm happy to help you your question. However, I couldn't find any information, so the system is clear. Allow me to explain limitations of our system. 1. Vocabulary mismatch. Most students normally use everyday language, yet our documents are using formal-based terms. 2. Grok API dependence. Answers need live internet connection. Without internet, you can't get the answers. 3. Static knowledge base. Manual build is needed when policies update. So when Makerere University updates one of its policies, we also have to manually update our system. Lastly, no conversational memory. Each question is treated independently, so the system does not remember what was said in a previous message. Next, I will talk about the future work. 1. Multilingual support. We need to support multiple languages. For example, Uganda and Swahili for local students. 2. Cross-encoder ranking to improve broad query results. 3. Student feedback system. We need to implement this to improve retrieval over time. Lastly, conversational memory for follow-up questions. So we need to ensure that our system can remember what was said in the previous message.